Hey there, and welcome. Have you ever stopped to wonder how the incredibly complex software we use every single day actually gets built? Well, today we're going to pull back that curtain and take a look at the architect's journey. So let's just dive right in. Think about that one app you can't live without. You know, the one for shopping, or streaming, or chatting with your friends. How on earth does something like that go from just a spark of an idea to this polished, totally reliable product that just works in the palm of your hand? It's a fantastic question, and it takes us right to the heart of software engineering. And really, the secret is this. Building great software isn't like quickly throwing together a garden shed in your backyard. No, it's much more like building a massive skyscraper. You absolutely need a meticulous plan, a rock-solid foundation, and crystal-clear blueprints. Without them, the whole thing is just destined to come crashing down. And that's the central idea we're going to build on today. So here's our game plan. We're going to start with the foundation, the core principles. Then we'll look at the blueprints, the architectures and patterns. After that, we'll see how those plans are drawn up, understand the actual step-by-step construction process. And finally, we'll wrap it all up by looking at what makes that finished skyscraper stand tall and stay reliable. All right, first things first, the foundation. You see, just like a real architect has to obey the laws of physics, like gravity, a software architect has to follow a set of core principles. And these aren't just helpful suggestions. They are the fundamental rules that guarantee you're building something strong and stable. The very first, and maybe the most important of these principles, is modularity. The big idea here is that instead of trying to build one single, gigantic, messy block of code, you break the whole system down into smaller, independent, manageable pieces. We call these modules. You can almost think of them like prefabricated rooms for our skyscraper. And why do this? Well, the payoff is huge. It just makes everything easier. If you need to fix a bug, you're only looking inside one small module, not the whole building. If you need to test a new feature, you just test that one module. It even means different teams can work on different modules all at the same time without tripping over each other. It's a total game changer. So, for example, think about an online shopping app. The payment module, the part that handles your credit card, is kept completely separate from the search module that you use to find products. So if there's a bug in the search bar, it's not going to bring down the payment system. And that right there is modularity in action. Okay, our next core principle is called abstraction. And this one is all about taming complexity. The whole point is to hide all the messy, complicated inner workings of a module and only show the simple, essential controls you need to actually use it. Here's a perfect analogy. When you drive a car, you only need to know how to use the steering wheel, the gas pedal, and the brakes, right? You don't need to be an expert on internal combustion or how the transmission works. Well, great software design is exactly the same. It gives you simple controls for a very complex machine humming away under the hood. Now, to really nail modular design, architects follow this golden rule. Aim for low coupling and high cohesion. Low coupling just means your modules are independent. They're like Lego bricks. You can swap one out without breaking all the others. And high cohesion means that everything inside a single module is laser focused on doing one job and one job only. Get that combination right, and you've got yourself a fantastic foundation. Okay, so our foundation is poured and the principles are set. Now it's time to start drawing up the high-level blueprints, the big architectural plans that are going to define the overall shape and structure of our software skyscraper. A really common blueprint you'll see everywhere is the layered architecture. It neatly separates the software into different floors, each with its own job. Up at the top, you've got the presentation layer. That's the user interface, everything you see and click on. In the middle, you have the business layer. This is the brains of the operation, where all the rules and logic live. And down at the bottom, there's the data layer, which is like the basement where all the information is safely stored. Another super popular pattern is called MVC, which stands for Model View Controller. It's just a really clever way to keep your code organized. The model handles all the data and the logic. The view is what the user actually sees on their screen. And the controller, it acts like a traffic cop, directing all the communication between the model and the view. So you hear this word patterns a lot. But what are they, really? Well, think of them as a toolbox, just filled with pre-made, time-tested solutions to common problems. So when an architect runs into a challenge, like, how do I add new features without breaking old ones? They don't have to reinvent the wheel. They can just reach into the toolbox and pull out the perfect pattern for the job. For example, there's a fun one called the decorator pattern. It's kind of like adding toppings to a pizza. It lets you add new features on the fly without changing the original pizza dough. So you can add pepperoni, you can add mushrooms, whatever you want, all without having to bake a brand new pizza from scratch. Okay, so we have our principles and our high-level blueprints. But how do architects actually, draw these plans so that the builders, the developers, can understand them? Well, they use a standard visual language called UML, which stands for Unified Modeling Language. Now, UML might look a little intimidating at first glance, but the basics are actually pretty simple. You use a solid circle for the start of a process, a rectangle for an action, like search for a book, and then a diamond shape for a decision point, like is the book in stock. By just connecting these few shapes, architects can map out incredibly complex workflows that everybody on the team can understand at a glance. Now that we have our detailed blueprints drawn in UML, we are ready for construction. And this is not some chaotic free-for-all. No way. It follows a very methodical step-by-step process called the Software Development Lifecycle, or SDLC. This is basically our construction schedule. One of the classic schedules is something called the waterfall model. It's very linear. You do one step completely, and only then do you move to the next, just like a waterfall cascading down. So first, you gather all the requirements. Then you design everything. Then you code everything. It's very structured, but it's not very flexible if things need to change halfway through. So for those more complex, towering skyscrapers, architects often turn to a more flexible plan, like the spiral model. This process works in cycles, or spirals. In each loop, you figure out your goals, you identify the biggest risks, you build a little piece of the project, you test it, and then you plan the next spiral. It's pretty much perfect for those huge, high-risk projects where you know you're going to need to adapt as you go. So there we have it. We've gone all the way from foundational principles to detailed blueprints to the final construction process. And this whole journey, this whole thing, has just one ultimate goal: to turn a simple idea into a final, reliable, and enduring software skyscraper that's built to last. And what does that finished product actually look like? Well, a well-built app has these key qualities. It's correct, it does what it's supposed to do. It's reliable, it doesn't crash on you. It's efficient, so it's not a memory hog. It's maintainable, meaning it's easy to fix and update, and of course it has to be user-friendly. Every single one of these qualities is a direct result of all that careful planning and structure we just talked about. So the next time you open up your favorite app, just take a second to appreciate the invisible architecture holding it all together. Think about the modular design, the layered blueprints, and the careful step-by-step process that makes sure it all just works seamlessly. What's the unseen blueprint that's holding it all together?